The next section of equilibrium has to do with heterogeneous equilibria. If you go back to the previous problems that we have worked so far, you will notice that all of the reactants and all the products are as a gas, which means that they are a homogeneous equilibrium and all the reactants and products are in the same phase. A heterogeneous equilibrium has reactants and products in more than one phase. So they can be a solid and a gas, a solid and an aqueous, a solid and a liquid, gases and liquids, all kinds of different possibilities there. When you want to write an equilibrium expression, you want to ignore the pure liquids and the pure solids, so that what is included in an equilibrium expression is the aqueous and gases. Oops, I can't spell. So you ignore pure liquids and pure solids. So if you look at the fact that there are four phases, there's gas, liquid, solid, and aqueous. These two are included. And these two are not included. Okay. And the picture I have here at the bottom shows you the reaction. 2 carbon oxides goes to form carbon dioxide plus carbon. And what's important here is this carbon here is in the solid, so this is a heterogeneous equilibria because I have gas, gas, solid, so I have more than one phase present. And what you see here is the carbon here versus the carbon here. There's a lot more carbon in this reaction. But if you were to count up the carbon dioxide and the carbon monoxide at the same temperature, there's the same number of molecules. So the amount of carbon does not play a part in the overall equilibrium, which is why we do not include the solids and the liquids in the equilibrium expression. Okay? So we're going to do some problems of writing what the equilibrium constant expression would be. So what you want to do is you want to pay attention to now the problems. Okay, so this one's a solid, so it's not included, and have aqueous and aqueous, so those are included. So my Kc would simply be the concentration of calcium, 2+, over the concentration of chloride, minus, squared. And then there's no denominator because I did not include the calcium chloride. If I go through the next one here, well, I suggest you pause and fill out the rest of them. Okay, if I do the next one, I do not have magnesium oxide because of the fact that it's solid. I do not have magnesium sulfide, or carbonate, sorry, because it's a solid. So therefore my Kc expression, now I don't have any products, so I have no numerator, but I have to put something there to make it a fraction. So it's going to be 1 over the carbon dioxide concentration. Okay. Zinc oxide and zinc are not included, so my Kc simply is my carbon dioxide over my carbon monoxide. And this last one, I have aqueous, liquid, aqueous, and aqueous, so the liquid's not included. So Kc becomes a concentration of H3O plus times C2H3O2, which is acetate ion, over the HC2H3O2 concentration. This is going to be a type of reaction that we're going to be doing in chapter 16. This is basically a weak acid dissociating in water, but instead of forming all products like a strong acid does, it forms both the products and the weak acid are there. Okay, And so that is heterogeneous. So whenever you have, so if you're given an equation and it asks you to write the equilibrium constant expression for it, make sure that you pay attention to what the phase labels are and do not include the solids or the liquids. And that's the end of this section.